Hi everyone, hope you are doing well. I am here to share with you all simple strategies for cracking JEE this year. Let me introduce about myself. I am Uma Shankar and this is my brief introduction. I have cracked IIT JEE and AIEEE in 2007. I cracked GATE All India Rank 6 in 2011. I have done my BTech from NIT Trichy. I have working experience in Microsoft project in Infosys around 2 years. Then I have been doing research as a PhD scholar in IIT Chennai for the last several years. And I have presented various research papers in many international and national conferences. Besides this, I have a lot of teaching experience for JEE for the last 10 years or so. Here I am going to share my experience with you all. How to score better in the coming JEE and what are some of the important tips which can be followed in this period of time. So let us begin this session. So I am here first presenting the total units. How many units are covered in JEE in physics? If you see, we have 10 units of grade 11. This is grade 11 and this is grade 12 topics. So starting from the physics and measurement and till the last oscillation and waves, and then in grade 12 topics electrostatics to communication systems. So there are certain important topics in these chapters, how you can spend your time more in particular hot topics as compared to some topics which may not be very much relevant, but you have to of course cover everything in this stipulated period of time. But how you are going to give priorities, that is what we are going to discuss. Okay, so I will be discussing each chapter, what are the important topics where you can focus. Anyway, you have to revise each of them, so on which areas you can spend more time. So let us start. So first of all, this physics and measurement, units and measurement, this is a very general topic. And if at all questions are coming in JEE, questions are coming from dimensional analysis or error analysis. Now when I say dimensional analysis, this can include quantities which is in your grade 11 or in grade 12. For example, magnetic flux. What is the dimensional analysis of magnetic flux? What is the dimensional formula for electric flux? What is the dimensional formula for magnetic moment? So whenever you are studying those quantities, also you need to also see how you can calculate the magnetic flux and the dimensional formulas of all such quantities in terms of fundamental quantities, you know that. So for that you have to also see or look for some questions in the previous years how they have asked. Recently also they have asked questions based on this, but sometimes they ask questions like they change the fundamental quantities. Like suppose in mechanics you take length, mass, time as fundamental, and then you write speed is Lt minus 1. But suppose they say speed itself is fundamental, then how will be length and how will be time and how other quantities can be expressed? So such questions have been asked, and like this type of question by twisting the fundamentals, they ask questions. In error analysis, if you see, so error analysis, generally the questions are from relative error, percentage error, accuracy and all that. But this concept is something which can be applied in any other chapter. For example, its application if you see to calculate the percentage error. I will give you one simple example. Let us say you calculate the range u square sine 2 theta by g, right? So if speed is changing, changing, suppose speed changes by 10%, 20%, range changes, you can calculate the percentage change. But when the quantities are changing very small percentage, let us say 4%, 5%, then you can use error analysis or relative error or percentage error to calculate that. So you will use delta r by r into 100 as 2 into delta u by u into 100, right? So to calculate percentage and all this can be used in general for any type of calculations. So that's a general concept, and we should also know its limitation, where you can use it. If it is going more than 5%, 10%, you cannot use this approach, because this error percentage are very very small, then only you can calculate it. Okay, so but this topic is general and it has got some weightage, less weightage, but it has got some weightage. Always one question at least you can find in JEE. Okay, then let us go to kinematics. Kinematics is very important, and the questions of kinematics can be framed or clubbed together with other chapters, other concepts, because it has got its application. So velocity has got application. Let us say a charged particle is moving, then how its velocity is in a magnetic field is, let us say it's going a circular motion. So how the velocity is changing, what is acceleration and all that. The concept of instantaneous and average is important, because when you say about instantaneous, then mathematics comes dy by dx, right? For example, dx by dt, dv by dt. Okay, all these are instantaneous quantities, instantaneous velocity, instantaneous acceleration. But when you take average, that means you have to take over interval of time, and graphical concepts are important, because in the graph you can represent the slope. Dy by dx represent the slope, and under the graph area represent integration. So this concept, okay, these concepts are important because they are related with many fundamental definitions of these quantities, and you need to look for its applications. Generally, we think about uniform motion or uniform acceleration, but questions which are non-uniform acceleration, there you can involve more about this differentiation and integration concepts. Okay, so they can be asked in motion one dimension, two dimension, projectile and circular motion. Sometimes questions of vectors and calculus can be combined in that. For example, if your body is moving in a different, path, then the average velocity, average acceleration. Let us say if your body is moving like this. So how do you calculate average velocity between point 1 and point 2? So you need to see the vectors, how the vectors are there, v1 vector, v2 vector. If I have to calculate average acceleration, then I have to use delta v vector by delta t, that is average acceleration, right? Similarly, we have average, is velocity and other concepts. So lot of mathematical concepts comes here, calculus. It actually starts from this chapter onwards. So then next laws of motion is important, because in laws of motion you have got Newton's second law, and this second law has got application in almost all the chapters, and particularly in gravitation and rotational dynamics and work energy, as well as electrostatics, magnetism, everywhere this topic can be combined. Okay, so this is one application. Then friction and circular motion, forces in circular motion, centripetal force, then tangential force, then net force, whether the circular motion is uniform, non-uniform. Now kinematics and dynamics both can be combined. Sometimes they can combine kinematics part, they have to calculate, you have to calculate suppose acceleration. So if your body is going, let us say pendulum, a pendulum is moving in this path. Okay, so what will be the acceleration here? So certainly this is a non-uniform circular motion, so there will be a tangential acceleration and there will be a centripetal acceleration, right? And you have to find the resultant of both, like you need to add the factors. Okay, net acceleration. So there are various concepts of kinematics and dynamics which can be combined into some of these topics, but Newton's second law and its application has got a lot of importance in almost all chapters. Then concept of equilibrium or conservation of linear momentum, same thing will be applicable in also other chapters. So you have to focus this, try to work out more problems, see the previous year questions that have come based on this. You will see these principles are there are used to solve the problem. So you can focus on these important topics in this chapter. Then coming to work, energy and power. In this chapter particularly, you can focus work done by constant and variable force. Work done will be calculated as F dot displacement. Okay, if force is constant, and it is integration of F dot dr. If it is variable, if force vector is not constant, then force can change with time, force can change with position, force can change with velocity. Various kind of functions will be there. You have to look for solving such important cases. So each of these topics you have to cover and also see the important results in that. That's how you can quickly revise it. Then the application of work energy theorem and conservation of energy is very important, because work done is change of kinetic energy, can also be change of negative potential energy, minus of change of potential energy. So this will be used work energy theorem. But when to apply, how to apply, if there are conservative forces, if there are non-conservative forces, you have to see that these equations cannot be applied everywhere, but whenever there are some conditions, you have to look for those conditions themselves. So suppose there are no non-conservative forces, then you can write it. Otherwise, if there is non-conservative forces, then you have to write work done by non-conservative forces this side, because friction creates loss, and you need to basically add the magnitude, because this will be, you have to consider this as minus, because work done by friction itself is negative. So you can say that work done by the net force is always change of kinetic energy, or work done by the conservative forces plus work done by non-conservative forces is change of kinetic energy. Okay, then how to apply the change of potential energy? This application can only be done when you have energy conservation. Energy conservation. Okay. So when non-conservative forces are present, there is loss, then you have to include those. So you need to work out problems. These are the critical topics where you may get stuck. So you need to look for some problems like that. Then collision theory, completely based on momentum conservation, and it is also based on coefficient of restitution calculation. And there are various results on this. Better remember those results, because that will save a lot of time. Like two bodies are colliding, given the masses, given the velocities, what will be the velocity of a particular body after collision? Remember, there are direct formulas. If you remember it, you can save your time. Otherwise, you have to solve equations. You will write momentum conservation equation, you will write coefficient of equation, a restitution equation, and then you will solve it. It will take time, so you have to save your time. So better remember those results. Okay, so these are the important tips that you can take. You need to remember certain results by practicing portions. Okay, then next rotational motion, very high weightage, very high weightage this topic has got, because I have here listed small, but each of these topic has got lot of application. For example, center of mass has come this application in conservation of total linear momentum, because the bodies are colliding. These internal forces doesn't change the system's momentum. There you can apply that. Then moment of inertia, various results are there, many results are there. Moment of inertia calculation is there. Okay, for point masses which are rotating about axis, for continuous bodies which are rotating about axis, so many results are there, like point masses rotating about the axis, so I is equal to mr square. Then if there are various bodies like a rod, continuous rod, mass is distributed rotating about the end, ml square by 3. Okay, if the axis changes, different axis, then there will be different formulas. So you need to remember all these results. For also you need to know how to derive these results, because they are based on integration. So in general, you can always integrate dm into r square and perform the integration around the axis. Okay, then moment of force, torque, angular momentum, their very definition is very important. Definition, how to calculate that is important, and various questions based on that. Then analogy of, so if you remember all the linear motion, like force is mass into acceleration, speed is distance, but all those things can also be considered as analogy in this chapter. So you don't have to separately remember any formula. For example, force is mass into acceleration. Here torque is I into alpha. Okay, so there are various equations analogous, just like there is a translational equilibrium net force zero, similarly rotational equilibrium net torque zero. Torque will be two directional only, clockwise, anti-clockwise. You need to add or you need to subtract to find the net force, net torque, right? So there are various conditions. In condition for pure rolling, there are various assumptions that body is rolling without slipping, body can roll with slipping. If it is slipping, it cannot roll, it will just slide. Then how things will change, there are certain results on this which you need to go through and solve problems directly based on those results. It will give you a clear cut idea. Okay, then gravitation chapter. Gravitation chapter is a small chapter, not much weightage, but questions comes from Kepler's laws, binary stars, orbital velocity, gravitation potential, and escape velocities, and variation of G, acceleration due to gravity. So these are the important topics. So remember all these formulas, you write, practice it, revise it quickly, and go to the problems, see the previous year questions, and see how to approach those questions. That is important. Sometimes they changes, things. For example, we know the force is equal to G m1 m2 by r square. But sometimes they say, let us say instead of r square, we have r power n. Then how the formulas will be? So you have to be clear through each of these. You should know how to even derive those equations. Basically, these are based on integration and differentiation, and there are certain results like force is equal to minus du by dr, and all the results are there, right? Force vector is minus du by dr. In terms of vector, if you write, then you can write as minus dou u by dou x I cap minus dou u by dou y j cap minus dou u by dou z k cap. Basically, this is known as delta vector into dot product with u cap. Okay, not dot product, just this is acting on this. This is a operator which is acting. And what is this operator? This is also known as Laplace operator. You might have studied in other mathematical topics, because all these are mathematics. Dou by dou x I cap plus dou by dou y j cap plus dou by dou z k cap. So sometimes questions based on this also come, and these are all fundamental basic equations of mass which we have to apply. Okay, then coming to the next, properties of solid. Solid is not very large topic, very small, but liquids we have fluid mechanics, big topic. Okay, so in solids you can just look for Hooke's law, Young's modulus, all this relationship between the modulus. But in fluid mechanics we have various laws like Pascal's law, Stokes law. Terminal velocity is just a result based on that, and this Bernoulli's principle is a topic which I'll give more important, because there are a lot of questions and this is based on energy conservation, Bernoulli's principle, and it has got a lot of application. When fluid is moving at different levels, you can apply conservation of energy. Surface energy, surface tension, same but a small topic, angle of contact, bubbles, and these things are there. Then comes in JEE, they have clubbed together this topic also, like heat and thermal physics also have been clubbed together in this. So heat capacity, Cp, Cv, all other things. Then change of state, latent heat, heat transfer, conduction, convection, radiation. If you see radiation, this is a very important topic. Questions comes from radiation, Stephen's law. Stephen's law is there. Stephen's law, and there are various results based on that. Newton's law of cooling is there. So these topics are in convection. Generally, they don't ask. Conduction they can ask, because we have laws for conduction. Heat transfer depends on certain formulas are there. Based on that you have to see. So in this conduction and radiation you can focus more. Thermal expansion is very easy topic, nothing is there in thermal expansion. Bernoulli's principle in fluid mechanics you can focus. Okay, and its application you focus. So these are the important topics. All the formulas you should remember and the results as well, so that quickly you have to simply apply that. Let us say if you forget the formula, but still you have derived it. So you should also go through the derivation of these things. Then things will be very clear. Even if you forget within few seconds, you can derive the result. Okay. Then next coming thermodynamics. Thermodynamics, thermal equilibrium is important. Zeroth law of thermodynamics, that is not much important, but this heat work, internal energy concepts are important, graphical concepts are important like PV, indicator diagram, TS diagram, which is from second law. These are important. First law and second law are important in thermodynamics. Then Carnot engine is important and efficiency based on Carnot engine. 1 minus T1 by T2. This is for Carnot engine. Okay. Otherwise, general, cycle will be Q1 minus Q2, 1 minus Q1 by Q2. But Q1 by Q2 becomes T1 by T2 in a Carnot cycle. So these things are important. You have to see the graph, how the graph of PV TS can be calculated. Area under the graph is important. So work done is just area under PdV, and heat is nothing but area under TdS. These graphs are important. Okay, and how to use them, how to apply the first law, you have to see internal energy formula. So this chapter also overlaps with kinetic theory of gases, because gases are used in the system. So there are various processes, thermodynamic processes, right, like the isothermal, isobaric. Those processes are also important processes. And for each processes you have to see work done, heat, delta Q, delta W, all these things, internal energy, delta E, all these things. So there are a lot of formulas here in this chapter, you have to remember that. Then kinetic theory of gases, many equations are there, particularly the ideal gas equation. There are gas, ideal gas equation, gas laws, Boyle's law, Charles law, all these things. Okay, you need to go real gas equation, how the deviation happens. Some theoretical questions can be asked. Okay, when the deviation happens, like which of the following are not correct. The gases becomes ideal gas or real gas under certain circumstances. Okay, then there are assumptions. There are some theoretical questions that can be framed on that. But calculation wise, RMS, average, and most probable speed questions, numerical problems can come. Degrees of freedom, CP, CV, mean free path, mixture of gases, these are important topics and they can be clubbed together. Okay. Fine, then let us go to the next, oscillation and waves. Oscillation and waves is a important topic because SHM, particularly questions comes from SHM, spring mass system. So oscillation of a spring mass system without any frictional loss, that is called free oscillation. Then the formulas for energies. So x is equal to a sine omega t plus phi, the general equation, and then you can use it according to the condition. For example, body starts from mean position, then x is equal to a sine omega t, right? X is equal to a sine omega t, and x is equal to a cos omega t when it starts from mean extreme position. So this is from mean position, and this is from extreme position, from extreme position. So these equations, how to apply this, we should know. If the conditions in the question changes, you can apply in a different manner. But general equation you should remember, then results based on that, then kinetic energy formulas, potential energy, all this. Then damped oscillation also question comes, but rarely. But you should remember the formulas for damped oscillation. And resonance, questions can come from resonance, the condition for resonance. So you need to remember when the amplitude become very high, infinity. Okay. And wave motion, this wave related topics are important, they have got more weightage. Okay. So for example, progressive wave equation, then superposition, adding the amplitudes, finding the resultant intensities, interference pattern and all that. So this is also a topic which is related with light. Of course, here in grade 11 you studied only sound, but it is also related with light. So you need to focus on those topics. Then there are some results like organ pipe, fundamental node, harmonics. Doppler effect questions comes. Okay, beat question may not come, but Doppler effect is more important than beats. So these are the important topics here. You need to go through the important relationship, derivations, formulas. Keep everything in a formula sheet. Write it again, so that it will register in the mind. Then when you start working problem, it will come. Okay. Then next electrostatics. Yeah, then we start with 12 topics. Now starting with this electrostatics is a heavy chapter. There are many concepts in this. So Coulomb's law is main thing. There are various results based on Coulomb's law, forces, potential energy, all these things. Okay, fine. Then field concept, point charges, dipole, electric dipole. Okay, so there are torques on the dipole. All these important results are there, like dipole, minus charge, plus charge. Then electric field on the axis, electric field on the equatorial plane. All these important results you have to remember. You need to remember the exact formula, not just for short dipole. Short dipole is just a case. Okay, but exact formula you have to remember. Then uniform electric field. So torque acting on the dipole is P cross E. Then there are various results. Potential energy is minus P dot E. All these results you need to remember, so that you can apply. And you have to also see the derivations. You should be clear with the derivation, because if suppose they give at a different point, then how will you calculate? Okay. Then next, here in electrostatics itself, Gauss law is a major topic, because various applications of Gauss laws are there. Like for example, infinitely charged plate, then infinitely large sheet, then cell is there, then a conductor is there, solid conductor, then solid insulator, uniformly charged, plus everywhere. So there are various results on this. You need to go through this, all the important results, because questions, graphical based questions also come. For example, in a cell, the electric field graph is like discontinuous, but in a uniformly distributed charge, this is like a continuous graph. So various results you have to see. Previous year questions have come based on these results. Okay. Then Then mostly here Gauss law can also be used to calculate charge inside a closed surface. Suppose inside a closed surface there are Q1, Q2 charges, okay, and there are some charges outside. So net flux is equal to charge inside by epsilon naught. So Gauss law has multiple applications, not just to calculate electric field, but it can calculate charge inside, right? Because of symmetric charge distribution. Even if it is unsymmetric charge distribution, it can be used, because one time in JEE they have asked like linear charge distribution is there, and then we have to only calculate the uh, flux. So flux, if they ask to calculate flux, you can use either E dot dA integration, or just like write Gauss law. So left hand side, right hand side, both are used in Gauss law, but which is used when depends on what they are asking in the question. Okay. Then coming to other topics of electrostatics, capacitors and other things are important. Then capacitors in series, parallel, capacitor based circuit, energy stored, that questions also comes. Okay, so this electrostatics is a very vast chapter, got high weightage. Okay. Then current electricity is the next big chapter. There are a lot of concept. Ohm's law, this is important topic. Then questions based on series and parallel combinations of resistor. These topics are important. Then if you see the cells are important, internal resistance. So how a cell can be used as a discharging, charging, all that. Short circuiting of cells, combination of cells. Kirchhoff's law is a major application. Kirchhoff's law has got major application, because most of the problems of circuits can be solved, and there are special circuit like rotational phase meter, phase potentiometer. These things are important because they involve the application of Kirchhoff's law and other Ohm's law. So you need to go through the applications. Then coming to magnetic effect of current, Biot-Savart law is one important topic in that. Ampere's circuit law. There are various results: current carrying straight wire, infinite wire, long wire, or finite wire, or circular loop, or solenoid, isn't it? So there are various results. Based on this, you need to go through all the magnetic field formulas for this. Then force on moving charge, Lorentz force formula is important. Lorentz force. Okay. Then cross field, other things, cyclotron. These are important topics. If you see magnetic effect, there are other topics like magnetic moment, force on two current carrying wire in the same direction, opposite directions, forces per unit length. Okay, so magnetic moment is important. Torque. So you will be able to derive some analogy with the electrostatics chapter. So, for example, torque is equal to mu cross B if a coil is having a magnetic moment mu and magnetic field B at an angle theta. All these topics are important. Okay. So questions based on these topics are important. Then conversion of ammeter means galvanometer into ammeter voltmeter. There are some questions based on this. Previous year also they have asked questions based on galvanometer. So refer to these topics. Then magnetic effect of current and magnetism. There are other things like the um, Earth's magnetism. Also matter and magnetism is separate chapter, but that is part of this magnetism only. Okay, so here Earth's magnetic field calculation, horizontal component calculation, then magnetic behavior, ferromagnetic. There are some theoretical concepts, and there is Curie's law. So Curie's law, you can see questions based on Curie's law can come. Other things are theoretical points that you have to remember about paramagnetic, diamagnetic, ferromagnetic, how their susceptibility changes, magnetic susceptibility, permeability, how are they related. Hysteresis loop is important. That means BH graph. Okay, BH graph questions also come on BH graph. If it is a fat graph, it is a thin graph. They have got applications like fat graph is for permanent magnets, and this graph is for ferromagnets only. And for temporary magnets, they are like thin graph. So BH graph questions based on BH graph also comes. You need to go through the theories and look for the previous year problems. Then coming to the next, EMI and alternating current history. So here few questions are coming. Like most important topic is Faraday's law of electromagnetic induction, Lenz's law. Various results on Faraday's law are there, like motional EMF, then AC generator concept, all that. Then in AC we have this series LCR circuit. So series LCR circuit is important. You refer to series LCR circuit and the important equations and how to use phasor diagram. There is a very important concept of phasor diagram because everything depends on phasor diagram in this chapter. So you learn the technique of calculating problems, solving problems using phasor diagram. You can use it for series LCR circuit, even in parallel circuit it can be applied. Okay. Then formulas for resonance, quality factor, sharpness of resonance, these are important. Okay. Then transformer is just a very small topic, and it is just one or two formulas are there. Then electromagnetic waves is a very small topic. Here what is important is the applications of this wave. Radio waves, microwaves, infrared, visible, ultraviolet, gamma, all these has got some applications. Questions will come in application. Here you need to approximately at least remember the ranges of frequencies, ranges of wavelength. Okay, so it will be better if you remember the electromagnetic spectrum, how from one spectrum to another spectrum it goes. Generally quantitative based questions may come, but qualitative based is more chances because they can use to you can compare like which wave has got more energy, more frequency than the other. Okay, like gamma rays, X rays are getting more energy than other waves, right? So they have got applications, so application oriented questions can come. Then starting with optics. Optics has ray optics and wave optics. So if you take ray optics, in ray optics, these are the important topics. So reflection laws are there, surfaces are there like spherical surfaces, reflection, then reflection from spherical boundaries or lenses. These are important. Total internal reflection is important. Then you have prism, dispersion from prism. Then there are instruments like, for example, microscope, telescope. They are important. Okay, so how they are using the lenses, how two lenses they are using. One is a small focal length, one is large focal length. Some theoretical questions may come, or some numerical problems based on this. Okay, but wave optics is more important than ray optics. If you see wave optics, it has got more weightage. Okay, mostly in this Young double slit experiment or diffraction, questions can come from diffraction or Young's double slit experiment. Then microscope, telescope, resolving power is important. Then polarization concept like Malu's law, questions based on Malu's law comes. Okay, and then Brewster law, yeah, these Brewster laws, Malu's law, these two three things are important in wave optics. So Young double slit experiment, diffraction, then microscope, and this resolving power. Then in polarization we have this. Okay, so these are important hot topics in this chapter. Then other chapter coming to dual nature matter and radiation, we have photoelectric effect, important, Einstein equations, photoelectric effect, that is important. Then de Broglie relationship is important, lambda is equal to h upon p. Then experiment, you can refer to the recent German experiment, diffraction experiment, okay, of electron. That shows how electron behaves like a wave. Okay, that's a small topic. But now coming to this modern physics, this part of modern physics, where Bohr model is very important. Rutherford model and Bohr model is important. Then distance of closest approach, Rutherford model. And in Bohr model, the energy transition formulas, spectrum, hydrogen spectrum, Lyman series, Balmer series, Paschen series, all these are important. Then in nucleus, we have radioactivity, alpha, beta. So nuclear reactions you have to remember. So questions comes in nuclear reaction based on alpha emission, beta emission, gamma emission, and how the atomic number and mass number changes. These things are coming. And law of radioactivity also comes like after how many half cycles, how much fraction it will decay. Questions based on that. Then binding energy per nucleon questions comes. Yes, energy, binding energy per nucleon, and this graph is also important, that binding energy per nucleon versus mass number. Okay, so this graph is also important because it increases and then it goes like this. So here at iron 56 it is the most stable. Okay, for mass number 56 is the most stable, and then if you go like this side or other side, right hand side, it is unstable. So all the nuclear reactions try to happen in such a manner that they get the highest binding energy per nucleon to become more stable. Okay, so this graphical concept is important, look for it, because some previous year questions have been based on that. Okay, then semiconductors, if you see electronics devices, p-n junction diode is important. Then IV characteristics, questions on IV characteristics of special devices like LED, photodiode, and all these things, inner diode, very important. Okay. Then junction transistors are important because transistor-based questions come, application of transistor as amplifier. Okay, particularly common emitter configuration is mostly common. Okay, CE, common emitter configuration, but they can ask for different other configurations, but formulas remain same, formulas are not going to change. Oscillator, if you see logic gates, oscillator is also another application, oscillation circuit. Okay, transistor can act as amplifier or oscillator circuit. So see the applications of that. Logic gate, or and not. So one question comes based on logic gate. So you can remember, the formulas for logic gate, the logic diagram, and the Boolean algebra. So there are some Boolean algebra related with that. So Boolean algebra also you have to refer, because without drawing the diagram you can use Boolean algebra concept. Just draw a rough diagram and calculate a dot b plus b, and you can find the final result. Okay. Then last chapter, communication systems. Here you need to remember few important topics are there. What is that? Sky wave and space wave propagation is important. Then modulation is important, amplitude and frequency modulation. Other things, if at all question comes, that is based on some theoretical concept. Other numerical concept related things are only amplitude and frequency modulation, carrier waves, okay, how the frequency is combined, amplitude is combined, all that you need to look for that equations. Okay, these are the important topics in all these units where you can focus more. Other theories you can read here and there, but numerical problem you can focus on these things. Okay, now coming to the weightage wise, if you see the recent weightage of topics on which they have asked questions. So this is for grade 11. You can see the high weightage topic is rotational dynamics, work, power, energy. These are the highest. Others are scattered. And then kinetic theory in thermodynamics, this is also very high. Then this Newton laws of motion, as I told, the second law particularly has got a lot of application. Others are 5%. Sound waves also important. Kinematics means it will involve all other one dimension, two dimension, even three dimensional motions can also be coming. So if you have got the concept of vectors, then you can use it. Three dimensional motion also can be written in terms of vectors. Okay, so these are all the important weightages you can see. So now you'll get an idea about how much you can focus, which topic you can focus more, right? And some of these topics are also combined together. So for example, in rotational dynamics, even the concept of circular motion will come, v is equal to omega r and all that. Okay, what type of motion it is, and how much angular displacement is happening, what is the frequencies and all that. Okay, so rotational dynamics, beside that it will cover the moment of inertia, the angular momentum, torque and all that. Okay, so this is a very important topic and most difficult because there are various results in that. Okay, and most of students tend to forget those results. So remember that result, pure rolling is also a very important topic and there are formulas based on that. Work, energy, power is a very overall chapter because almost all the things will come in this. All the topics will come because energy conservation, work energy theorem, it can be used. So energy analysis as well as force analysis can be done. Then coming to the grade 12 topics, if you see this means how the weightage has distributed, you can see here that current electricity has got very high weightage. Electrostatics, I have separated it only for Coulomb's law and capacitors separate because capacitor based circuits are also coming. Okay, and even in current electricity, capacitors can be just combined together. Then wave optics, as I told, wave optics has got very large weightage here, and moving charges magnetism and earth's magnetism, all this has got lot of weightages. EMI and AC, particularly EMI has got more electromagnetic induction and alternating current. They may sometimes also involve some concept of circuits because average power they can ask, or the root mean velocity they can ask, all these questions based on that, circuits based questions. Series LCR circuit is most important in AC. Okay, then modern physics you have atoms, nucleus and all that. Okay, so most of them is Bohr model, questions based on Bohr model or hydrogen spectrum, as I told. So as I highlighted all the important topics in these chapters, you can focus on those topics to get very high score. So how to effectively utilize time? The thing is that you need to go through and focus on those particular topics which have got more weightage. Each chapter has got many topics, but those topics which are more relevant, on which questions are framed, you can focus on that. Now, what is the strategy to score very high marks? Okay, so the first thing is that if you have to get through all the things, just quickly revise. Take each chapter, write all the important equations, all the formulas, all the important results, and try some questions on that. So first, quick revision of each chapter is important for you. Quickly revise it. It won't take much time. You can revise each chapters. Then focus on high weightage topic. As I have highlighted all those important topics, you can focus. Okay, that's the second thing you can do. So while revising itself, you can mark out these are the important topics, important weightage JEE has asked previous year. So that's why you have to practice the previous year questions. Look for previous year question. Let us say you have taken topic first, error analysis and dimension analysis. Look for previous year questions. See how many questions have come. Recent years you see there have been some questions. Try that. Are you able to do that? Or where are you stuck in? Is there any conceptual gap? Go back and see the concept and then again attempt. Don't try to mug up, because mugging up thing will never help. Because when things changes, then you will face a problem. So it is better to clear the concept by quick revision and see the problems, previous year problems and the high weightage topics. Then time management is an important skill that you have to you know get. How will you do that? You have to sit for mock exam. You set up question papers and try to see how you are able to perform in that. Time management means you have to, suppose so many questions are there, you have to first of all uh, give your effort in those which you can exactly do 100%. But suppose some questions are taking more time and you are not able to do, you got stuck, you have to skip that. You cannot invest more time because you have to manage the time, isn't it? So based on this, time management is a very important skills. You have to give priority to those questions which you know, which is your strength, and then skip some questions which is your weak areas. So those weak areas you have to identify during the practice itself. While you are doing this step 1 and step 2 and step 3, you will understand what is your weak areas to try to improve that. And then while you are doing this final like a mock test, you will get to know your time management skills, how much are you able to perform. So this self assessment you can do. So this daily you need to do this 4 step. If you daily practice this, daily try to do quick revision of chapters and see which are important weightage, underline it, highlight it, and see previous year questions, and then just uh, try one mock paper. With that you will get some idea about how you are able to perform. So this is the overall strategy which I shared. I shared all the important topics of each chapter which has got more weightages in the recent years, recent JEE papers. And this strategy, if you follow, certainly this will be very much helpful, because as time is limited, you cannot do thousands of things, but just choose few things and become master in that few things, and then you can learn. See, so this is what is important to build up your confidence. Okay, don't have to go through which is very very weak areas. Let us say you have some weak areas, just see how the questions are asked. If you are facing a lot of difficulty in that, just see how the questions are approached. Don't have to go through more theory. If you go, then it is a big waste of time. So try to keep focus on the high weightage topic, see the important relevant theory, and go to the problems, because that's more important. And I would like to wish all of you all the best for the coming exam. Thank you all for